Dance Heretics. This is iteration 10 of Petre's AI project, aka Pipe. My name is Petre, and let's start. For today, I wish I could have found all my notes, as I said in the previous video, about first principles thinking. But even after a few hours of digging, I couldn't finish grabbing the most important ideas of first principles from my notes, because there are so many things related to first principles. I didn't expect me to take so long. So for now, I will not add those ideas yet. I will marinate them a little bit longer in my notes. Maybe I will bring them little by little here, but I think I will delay this for now. So let's see how those ideas can occur naturally. And my plan is first to integrate back the previous iterations into the structure of the project, and then I will start investing more time just in exploring and understanding first principles thinking, because I think it's such a way, a really powerful way of thinking, which people don't use accordingly and properly. And I think we should do some justice to that. So that's our general thoughts for this iteration. According to our structure, we should create the iteration 10 here. And let's integrate the previous day, which was number 5, a small idea here. I think this is when I started to integrate previous days. So now it should become easier to integrate them. Let's see. This is like a thinking principle, so should come into the principles of thinking, metacognitive skills. For the purpose of integrating new ideas into the structure of the project, we are reviewing the ideas which we have collected during the idea gathering phase. So that's something. There is an idea gathering phase. For example, brainstorming, field research, SOTA research, review papers of the field, and so on. The idea gathering can be from many sources, such as memory, observation, internet, search, discussions with other people, and dialogue. These are just a few. That's a principle, I said here, a thinking principle. Is it a first principle? Well, we didn't integrate yet the first principle. I think we should not ask this question yet. This is something powerful, I know that. Sometimes you need to do research, and the ability to do research greatly increases the performance of AI models today. We will put it to the principles for now. It's not something that you should always do, not always necessary, but powerful. Maybe later we could, let's add a to-do here. To decide when is necessary and when it is not let's talk about it a little bit in iteration 10. ChatGPT sometimes goes and searches the web for before answering, but sometimes it is able to just come with an answer. When uh, I I'm not familiar with when is it a good idea to search and when is it a good idea to just answer. That must be based somehow in a confidence metric for answering the question correctly. So here there is the principle that there is the limitation that we have talked previously, uh, to not know that it doesn't know, to fail, mm, to give a failed solution and to hallucinate is because, for example, the style of the answer is forcefully nuanced. But hallucinations are really related to confidence. And the concept of confidence should exist in a system to give better answers, even if better means I don't know. Because confidently giving a wrong answer is worse than saying I don't know. So that's an important thing to highlight. Nice, this was an easy iteration for us. Let's move on to iteration number 6, where we started to review and integrate again. So Apple example of the Tower of Hanoi. I have seen many videos where Apple tries to show that models start to struggle answering questions really fast when the questions become more complex. And I made an assumption here that it is based on giving the most popular answer instead of the best answer. Mm, I I should read this paper because I think it's I think no I think they just highlight the limitation that LLMs fall off a cliff when problems start to become more complex. That's what they have observed in that paper. I don't know based on what, like, what's the reason behind this catastrophic, like, catastrophic failure with just a little bit more complex problems. complexity is something that humans also struggle a lot with. Complexity is something that humans struggle with. I think we have talked about that in a previous day. I won't go back. We will review them one at a time. But the idea, maybe even if with the risk of repeating myself from a previous iteration, complexity is something that humans struggle with. It's not about creativity. I don't think we wrote here about complexity except when we started now. So humans, I think this was an interesting topic for me at some point when I started to become when I became a professional programmer, when I started to work as a programmer, as a software engineer. I noticed that humans use techniques to manage the complexity of a problem. And this is really obvious in programming. To manage the complexity of so many components that interact with each other, and rules and behaviors, I think this is maybe the most important thing in programming, and it's also one of the most important things in every kind of thinking. The concept is constructing layers of abstraction. Maybe the most important concept in software engineering is managing layers of abstraction. This is how we have found a trick to manage complexity. We hide this complexity in abstractions, and we only deal with a few components. We hide the complexity in abstractions and only deal with a few components which are necessary for the part of the system that we want to build at the moment. That's how we think. And people have noticed that LLMs fail somehow to use this technique, but we can use it, and we can navigate those layers of abstraction. In navigating those layers of abstraction, we can hide unnecessary concepts to solve a tiny piece of the system and make incremental progress. We kind of forget, because of our limited working memory, we forget it is outside of our working memory. Everything that is not necessary at the moment to make a tiny increment progress of the problem. LLMs don't do this. LLMs do something completely reverse here. LLMs keep everything in the context memory, in the context window, in the working memory, which we are doing as an analogy the context window. Because they have everything in the context window, they are not forced to do this navigation and managing of abstraction layers, which we do. They don't have to deal with abstraction layers. So maybe because they don't use those abstraction layers, they fail to solve problems that humans can. That's another key concept that will eventually be integrated here. I have wrote about it a little bit here. Let's see. Because I am developing that idea in the today, but I didn't add it to the structure. Maybe I even have repeated myself from a previous day. So let's see, where do we add this? I said it's a limitation. Okay. Sure. Having to review and edit the code yourself. That's a principle. Looking at ideas with fresh eyes after some time is a process of review. It's a key component which we will have to have in our system. And when we review, we are looking for mistakes. That's a connection with the previous idea. Making mistakes is we first do things, we don't know if they are mistakes, but in the review process, we are looking for the mistakes. Oops. Sorry. So in the process of looking for the mistakes and finding mistakes is a key principle here. First principle is that I want to, so these two principles, I wrote them here because I eventually wanted to start building something. These are theories. This is an unfinished idea. I will put it in other ideas category, and I will also add a new category here, a new chapter, which is the implementation. Since the system will answer the questions for the user in language, that's the first principle which we will have to use in our system. And at the moment, the best interface natural language interface technology are LLMs. They are good for formatting the answer and ingesting the answer. We will have an API call to an LLM to ingest ideas and deliver ideas, deliver answers, to ingest questions, deliver answers to the user. So about the second thing, since the system should be also be a competent programmer, it should also be able to program itself, since itself is software. So in order to program itself, it should be similar to Cursor maybe, or there is Codex, another system from OpenAI, and those two are a great starting point for us to even start writing some code. I feel that something is missing from this idea. Yeah, the solution about it, I wrote it here now. I think this is good enough for today. For this iteration 10, we have been discussing about confidence, complexity, and abstraction. Very interesting to me, at least. Maybe it's not for you, maybe it is. I don't have I don't think I have any audience at the moment. Maybe I will continue making hundreds of videos by myself. You see, even if nobody watches me, I'm talking to myself here like a crazy man. But for me, this gives me dopamine, and I like this, to observe how these very interesting ideas emerge in trying to solve this problem and finding how LLMs fail and how humans manage to do things. So that's enough for today. See you next time. Have a nice day.